Okay, so just to help us with this lesson a little bit, I want to recall x-intercepts and how they relate to factors. So I want you to take a minute, pause the video, and identify the x-intercepts of this graph and identify the factors. With you understand the x-intercepts, you should be able to do. So pause the video, do that, and unpause when you're ready to discuss. All right, so hopefully you recognize that at -1, at 0, at 1, and at 2, we have our x-intercepts. Now I wrote them as coordinate points because it helps us to recall that the y-coordinate is always 0 when we have an x-intercept. The x-coordinate can be 0 also, because 0, 0 is both an x and a y-intercept, but the y-coordinate has to be 0 if it's an x-intercept. Now, how do we turn those into factors? Remember, the factor is the opposite of this number. So if the x-intercept is at x equals -1, then the factor is x plus 1. If the x-intercept is at 0, then we would usually just write x. Now, you could write x plus 0 or x minus 0 because those are still the same thing, but normally we just write x. If the x-intercept is at +1, then the factor would be x minus 1. And if the x-intercept is at +2, then the factor is x minus 2. All right, any questions on that? Okay, you guys are quiet. All right. So the reason why we care about that is because it's going to help us with what we're going to learn today, which is the factor theorem. So the factor theorem tells us that a polynomial, f of x, has a factor, x minus k, if and only if f of k equals 0. Great. What does that mean? Well, what it means is if we take a polynomial, f of x, and we divide it by something that is of the form x minus k, if the remainder is 0, then x minus k is a factor of that polynomial. Remember, we learned that from the remainder theorem, that the remainder is the same as the value we get. So let's look at an example of this, and hopefully it'll make a little more sense. So here we want to determine whether x plus 5 is a factor of this polynomial. So what we're going to do is synthetic division. So remember, for synthetic division, I'm going to take this here. I'm going to set it equal to 0, and I'm going to solve for x, and that's what I'm going to put in the corner. And this is going to relate to whether this comes out to be a factor or not. Think about what we just talked about with x-intercepts versus factors, that it's the opposite of the number, right? So that's what we're doing here. Now I take my coefficients, so 3, 15, -1, I have 0x, and then 25. So don't forget I need that placeholder here for 0. Then we can go ahead and do our synthetic division. We're adding 0. So this becomes 3. -5 times 3 is -15. 15 plus -15 is 0. -5 times 0 is 0. -1 plus 0 is -1. -5 times -1 is 5. 0 plus 5 is 5. -5 times 5 is -25. And 25 plus -25 is 0. So this is what we're looking for to determine if it is a factor. If this comes out to be 0, which it did here, then that means x plus 5 is a factor of this polynomial. What else does that mean? It means that when x is -5, there's an x-intercept. So that is what this tells us. That is what the factor theorem was telling us, that when we get 0, because remember that from our remainder theorem, if I plug this number into the polynomial, that's the same as doing the synthetic division. So our answer to the question, yes, x plus 5 is a factor of f of x. Okay, next one. Here I want you to show that x plus 3 is a factor of this polynomial. So I'm telling you it is a factor. Then I want you to take the result and factor it completely. So I want you to try this on your own. You should be able to do this. You have all the tools. Pause the video. Unpause when you're ready to check. All right, so we've got a lot going on this problem. So the first thing was I did my synthetic division. So I have x plus 3, set that equal to 0, I get negative 3, put negative 3 in the corner, take my coefficients, 1, 3, there are 0x squared, so I got to put that 0 in there, minus 1, and then minus 3. Add vertically, multiply diagonally, 1 plus 0 is 1, negative 3 times 1 is negative 3, 3 plus negative 3 is 0, negative 3 times 0 is 0, 0 plus 0 is 0, negative 3 times 0 is 0, negative 1 plus 0 is negative 1, negative 3 times negative 1 is positive 3, negative 3 plus 3 is 0. Boom. So show that x plus 3 is a factor. I got 0 as a remainder, therefore it is a factor. I showed it. Now, the next part is factor f of x completely. Well, this comes to my understanding of synthetic division. So my results, remember, if I started with x to the fourth, then this is x to the third. This would be 0x squared, 0x, and then minus 1. So I have x to the third minus 1, which coincidentally, I don't know why it's a coincidence actually, but this is the difference of cubes. So this is a perfect cube, this is a perfect cube, this is subtraction, therefore it's difference. So I used my difference of cubes pattern from a couple videos ago, and I factored. So this became x minus 1 times x squared plus x plus 1. Now remember, if I've done this correctly, this part will never factor into real numbers. So if I want to write f of x completely factored, at least in terms of real numbers, I still want my factor of x plus 3. So I have x plus 3 times x minus 1 times x squared plus x plus 1. And now, assuming I've done this correctly, if I was to multiply all of this back out by distributing, I should end up with x to the fourth plus 3x to the third minus x minus 3. I would also point out this problem here, we could have factored by grouping as well. Now, because this technique is what we're learning in this video, that's why I went through that, but I can see that this problem does factor by grouping. All right, let's try one more just to make sure we've got it. So I want you to show that x plus 2 is a factor of this, then factor completely. Pause the video, unpause when you're ready to check. All right, so first thing I did, I showed that x plus 2 is a factor of this polynomial. So x plus 2 equals 0, set that equals 0, get x equals negative 2, put that in the corner, take my coefficients, 1, negative 1, negative 24, negative 36, do my synthetic division, and I get 0 as a remainder. So that is showing that x plus 2 is a factor. Now, take the quotient, which is the result of the division, x squared minus 3x minus 18, brought that up here, and I factored it. What multiplies to negative 18, but adds to negative 3? Negative 6 times positive 3 is negative 18. Negative 6 plus 3 is negative 3. Those are my factors. And then don't forget x plus 2 is also a factor, right? We showed that. So f of x in what we would call a completely factored form, or as a product of linear factors, is x plus 2 times x minus 6 times x plus 3. Again, if I was to multiply all this out, it should get right back to that original polynomial. Nice work. Okay, so just to conclude this section, don't forget, if we got 4 terms, we factor by grouping. Always look for our greatest common factor first. And then we can use synthetic division to determine if a binomial is a factor of a polynomial by looking at the remainder. If the remainder is 0, that tells us, yes, it's a factor. It also, again, means we found an x-intercept. Nice work.